Hey everybody, I wanted to cover some long division. So let's go ahead and do this. So I've talked about long division, I've done some long division, but I don't think we've practiced it much. And I was concerned, what if it comes up on this year's test? So I want to go over some examples with you. And then I will post this worksheet, and you can, if you want to practice, there are solutions here for the long division. The completing the square, that's another topic that I have covered, but I don't think I'm going to go over that. I just don't think that's going to be on the test. So how do you integrate these? Well, the first thing that should stand out to you, and it's a big hint that you're going to do long division, the exponent, the order of the top polynomial is 2 on the number 7, and the bottom's 1. When the top has a bigger power than the bottom, that usually indicates it's going to be long division. And sometimes when the powers are the same, you can try U sub and all these things, and it usually is going to be a fail. So let's look at number 7. So you would see if you can factor and cancel, see if that works. It's not going to work in this case. You could try a U sub, you could try a lot of things, but it's not going to work. But the first thing you should do is try to factor and cancel, because if it does, that makes life a lot easier. So let's take a look at this. Long division. So here's what needs to happen. So you have to realize you have columns, x squared column, x column, and a constant column. So that's going to help you do the long division. And then you look at this one and that one. And all you do is ask yourself, hey, x times what will give me x squared? Clearly the answer is x. So in the x column, I put an x. Then just like any other division, you multiply these, and you have to distribute that. You get x squared plus x. And just like division you learned in probably 6th grade, I believe, you subtract. X squared minus x squared is 0. 4x minus x is 3x. And then, just like division in 6th grade, you bring the next term down, you get a minus 2. And now we go through the same process that we did for the first one. You look at the first term here and the first term here, and you ask yourself, what times x will give me 3x? And in the constant column, it's clearly plus 3. And then you distribute that again, you get 3x plus 3, and you subtract. 3x minus 3x is 0. Negative 2 minus 3 is negative 5. So what happens, I'm going to encroach on the right side here. What happens is this integral, number 7, the integral, I'll write it out. I don't want to, but I will. So your quotient is right here, x plus 3. That's the answer to the division. It's x plus 3. And then you take your remainder and put it over your divisor. So it's minus 5 over x plus 1. And now you just integrate like normal. X squared over 2 plus 3x. Now this last one is actually going to be a u sub. You're going to do u equal x plus 1, du equal dx. And when you do that, you'll end up with a minus 5 ln of absolute x plus 1 plus c. That should be the answer. Let's look down the bottom. Let's look. 1/2 x squared plus 3x minus 5. That doesn't sound right. Yeah, 1/2 x squared plus 3x minus 5 ln of absolute x plus 1. That scared me. Plus c. So, bam, we got that right. Let me go to number 9. And This one's a little trickier because if you look, it's not a case where, oh, wow, it's not even, okay. Wow, check this out. I guess they're testing you to make sure you don't do long division when you don't need to. This actually comes out to be a u sub. U equals x cubed minus 2 du equals 3x squared. Hey, do we have 3x squared? I don't, but if I do this, now I do, that all becomes du. So this nicely becomes 1/3 integral of du. That bottom part here is just u, so it's 1/3 ln absolute u plus c, 1/3 ln x cubed minus 2, whoops, plus c. Let's see if that comes out. 1/3 ln of x cubed minus 2 plus c. So, yeah, that's just a simple u sub. And the clue on that one, the top didn't have a bigger power. Let's jump down to another one. I want to see if there's a good one. Number 12, do you think that's going to be long division? Probably not, because the bottom doesn't have a bigger power. I'm not actually sure what that's going to be. Maybe, I don't know, let's see what they did down here. They did a u sub. Oh, they did a crazy u sub. Interesting. And then they got arctan. Yeah, that's a good one. Crazy. But it wasn't a long division, and the clue was that the top wasn't a bigger power than the bottom. All right. I guess what I want to do here, I guess I'm going to do number 8. I'm going to erase this. And the reason I want to do 8, it's slightly different, a little twist. And I'm not going to do the whole integration. I'm just going to do the division part for you. So we have x minus 2. And here's the thing. I'm going to put a 0x and a 0 because I want an x squared column, an x column, and a constant column. So this one looks different, but really isn't. So you look at x and x squared and ask yourself, x times what is x squared? Clearly x. So the x column, I put that there. We're going to distribute that. We need x squared minus 2x, and we'll subtract. X squared minus x squared is 0. 0 minus negative 2x is plus 2x. Bring down the next term, 0. And again, x squared times what gives us 2x? It's plus 2. Distribute, that's 2x minus 4. You subtract, you get 0, but you get plus 4. So this integral here would be the quotient, x plus 2, plus the remainder over the divisor. And now you do your stuff. Was it x squared over 2 plus 2x plus 4 ln of x minus 2? X squared over 2 plus 2x plus 4 ln, yeah. So that's that. So if you want to practice these, I will post that. But that is the video explanation. Bye-bye.